Back in the 90s, when I first started teaching in the early 90s, no, mid 90s, this is a junior high class, and I had a student who, it was funny, I was watching him do this the whole time, and he was looking at his pencil, looking at the light socket, looking at the pencil, looking at the light socket. You know where I'm going with this, right? I was thinking, there is no way he's going to do this. There's no way he's going to do this. Sure enough, he put the pencil in the light socket. That light show was impressive. This big spark comes out. His hair went poof. Yeah, it was kind of cool. But then he turned to me and he said, I didn't mean it. Funny. So it's what not to do. Okay? Here's something that I'm going to say what not to do. We're going to solve 3 over x minus 2 is less than 2. People may tell you to multiply x minus 2 over to the right side and then go ahead and solve it. I'm going to say don't do that. It's a dangerous thing because you might forget something. Okay? Particularly, there's going to be restriction right here with that denominator. So what to do? Okay, not going to lie, this problem's going to be a little on the rough side, okay? But hopefully I can guide you through this. What to do if one side is not a 0? Well, make it a 0. Subtract 2 to both sides. And right away, this is going to make it a little more challenging. 3 over x minus 2 is less than 0. So I got 0 over on the right side, but now I've got a mess on the left side, right, of the inequality. Well, I'm going to make this 2 a 2 over 1. Now, in order to subtract fractions, you need a common denominator, right? So I'm going to multiply top and bottom of this denominator on the second fraction here, this 2 over 1. I'm going to multiply top and bottom by x minus 2. Still less than 0. Now I have a common denominator, so I'm just going to rewrite that denominator. And my numerator is now 3 minus 2 times the quantity of x minus 2. And it's all less than 0. Okay? Let's come on up here and let's work this out now. I'm going to distribute that negative 2 through the x minus 2. So 3 minus 2x. And then negative 2 times the negative 2 is a positive 4. And it's all over x minus 2. And it's less than 0. Combining like terms on the numerator, I'll have a negative 2x plus 7 is all over x minus 2. And it's all less than 0. Now, if you've been watching parts 1 through, I think, 5, I think this is part 6 now, of solving nonlinear inequalities in one variable, the series that I put together here, you'll notice that my leading factor has always been positive. And in the numerator, notice I've got a negative 2x. All right, my leading, I didn't mean to say leading factor, I meant to say leading coefficient. So my leading coefficient in this numerator is negative. What I'm going to do is I'm going to factor out a negative 1 in that numerator. It's going to be a little bit easier, negative 1. It's going to make it a little easier for us to work with. Now when we do that, that's going to change the sign for both the negative 2x, see how it's now positive 2x, and the positive 7, see how it's now negative 7? If I was to distribute the negative 1 back through, I'd get negative 1 times 2x is negative 2x. Negative 1 times negative 7 is a positive 7. All right, now I'm going to multiply both sides of this inequality by a negative 1. What that does is negative times a negative is a positive, so I'll have a positive 2x minus 7 over x minus 2. So see how I now have the leading coefficient of the numerator and the denominator both positive? But look what else is happening. Since I'm multiplying across the inequality, my inequality will change, right? Anytime you multiply or divide by a negative value across the inequality, it's going to make the inequality change. So it's now going to be greater than 0. Okay, I'm going to hit pause here for just a minute while I erase the board and finish this problem off. All right, you still with me? So I erased this 2x minus 7 over x minus 2 is greater than 0. It was down here, but now I've transposed it up here after I've erased the board. If you'll notice, this is actually the starting point of, or very typical of a starting point that you would have seen in, I think, part 1 of this series, where I go ahead and put a number line down, and I look at the tipping points now. Let me look at this 2x minus 7. I'll set that equal to 0. It's a little harder because it's going to be a fraction. I'll add 7 to both sides, so 2x equals 7. So x will be 7/2. That's what, 3.5? So that'll be right here, 7/2. And then x minus 2, that's, solve that for x, you'll get 2. I'll show the work here, because you really want to see it. Alright, so my intervals that I'm going to be looking at are between -infinity and 2, and then 2 to 7/2, and then 7/2 to infinity. Now, if you watched part 1 and 2, particularly part 1 of my series, you'll notice that I used a shortcut, okay? And on this one, I can, C-A-N, use that shortcut because I have 2 factors, one in the numerator, one in the denominator. They're both raised to the power of 1. If I had 2x minus 7 raised to the power of 2 or something, I would no longer be able to use that shortcut. But on this one, I can. And what that shortcut is this. If my two factors, multiplied or divided together, are greater than 0, my answer is going to be the 2 outside intervals and not the middle intervals. So I've done like 6 of these so far, and in all of them I think I've tested them, all the different intervals. So I'm not going to do that this time. If you want to see how to test intervals, you go find them yourself, okay? But your answer is going to be between -infinity and 2, and then 7/2 to infinity, parentheses all the way across the board because it's not greater than or equal to. And since I have 2 intervals, I'm going to link them with the union sign. So there is your answer right there. Okay, that sums it up for the series of videos that I put together for solving nonlinear inequalities in one variable.